In the new Adam McKay movie, Don't Look Up, astronomers identify a comet heading towards Earth, and politicians are slow to respond.
And then what happens, like a tidal wave?
Wired talked to Dr. Amy Mainzer, a real-life astronomer who consulted on the film.
Let's take a look at a couple of scenes from the movie Don't Look Up and explore the science behind near-Earth objects.
It's got to be an Oort cloud comet just based on where you saw it. Probably the last time it was this close to the sun was long before human civilization. Look at the arc on that thing.
A near-Earth object is any asteroid or comet that approaches the sun within about 30% more distance from the Earth to the sun. So in other words, it just sort of has to get close to the region of the Earth and the sun in our part of the solar system. NASA has a near-Earth object observations program, and that's a network of telescopes all around the world and even in space that are systematically searching for asteroids and comets that can get close to the Earth's orbit. When we first discover a new object, we have a lot of work to do to figure out what it is. The images that you see in the movie where they're looking at these exposures of the comet kind of marching across the sky, those are actually images that I took from our NEOWISE mission and made them a little bit larger so you can see them. And from that, we need to figure out where it's going. And we need to make sure that it's a real object and not just noise or confusion with a background source. So when we first get these observations, the first thing we do is we make a list of their dates, times, and positions, and then we send that to something called the Minor Planet Center. And this is a place that has a huge database of all the known asteroids and comets that are out there. And then they play this game of connect the dots, basically, to try to figure out if this is something that we have already seen before. If they can't make a match, then it becomes a candidate for a new discovery. And at that point, the news goes public.
To Comet DiBiase, right? Cheers.
Right. There are a lot of rules that govern the naming of bodies in space. In the case of the comet that's discovered in the movie, Kate DiBiase, who's a PhD candidate, and traditionally it would probably take her name. It would probably become Comet DiBiase, so that's pretty realistic. Usually that whole process of collecting the data, identifying the candidate new objects, and getting them posted on the Minor Planet Center's public website, that's pretty fast, and that usually happens in less than a day.
Just tell us what it is.
He quickly figures out that this object is very likely to have come from the Oort cloud. You can kind of think of it as a cloud or a shell of comets that surrounds the planets in our solar system. We actually had to kind of make up a comet specially for this movie that would have the characteristics that we would want for it to kind of drive the plot forward. I designed the comet to be about 9 kilometers across, which is pretty typical and not an unusual size for a comet of this type. But the thing is, such a large object would come in from that distant outer part of the solar system, the kind of frozen outer dark, if you will, and would come in towards the Earth with incredible speed. That's kind of one of the reasons we pay attention to these long-period comets. They can be pretty big, and they can move with incredible velocities.
How would we find out the comet's velocity in orbit, Professor Mindy?
That is a good question. Well, this will be fun. I haven't done orbital dynamics since grad school.
In the movie, we see Dr. Mindy using what I would call kind of a classical method of orbit determination called Gauss's method. And it's basically the idea that you sort of iteratively solve for where the object is actually going in 3 dimensions based on the 2-dimensional motion that we see on the sky. The math is there, and that is the real math we would use, but we'd probably use a computer. You have to remember, space is incredibly, incredibly huge. So the odds of any of these objects ever getting close to the Earth, let alone having an impact, are just incredibly rare. So most of the time when we find something, it's a huge cause for celebration because it's going to bring us new scientific knowledge and it has no chance of impacting the Earth whatsoever.
There's a party. I'm just so thrilled for you, Kate.
The nature of what would happen if an object were to impact the Earth really depends on a few things. It depends on its velocity. It depends on its size. This is because the kinetic energy, that impact energy, it scales as velocity squared, and then also the size. Kinetic energy goes as size cubed. So small changes in size make a very big change in the impact energy. What happens depends very greatly on those parameters. The Earth's atmosphere is really good at screening out objects below about, say, 20 meters across, so kind of the size of a house. Anything smaller than that, the Earth's atmosphere is effectively a brick wall, and the object slams into it and is shattered into a zillion pieces. By the time you get to something that's the size of, say, 100 meters across, or say a football field, now we're talking about something that really could cause severe regional damage.
There will be mile-high tsunamis fanning out all across the globe. If this comet makes impact, it will have the power of 1 billion Hiroshima bombs. There will be magnitude 10 or 11 earthquakes.
You're breathing weird. It's making me uncomfortable.
I'm sorry, I'm just trying to articulate the science.
I know, but it's like so stressful. I like trying to like listen.
If we have enough time, there are a lot of different options available to us. If we have, years to decades away from any potential impact, you've got things that are as simple as just bumping into the object. We call that a kinetic impact. You just basically take a spacecraft, you load it into a rocket, and you send it into the path of the comet or the asteroid. And nature takes its course. Boom. NASA is about to launch a mission called DART, the Double Asteroid Redirect Test. And in this mission, they're going to take a spacecraft and they're actually going to deliberately run it into an asteroid, specifically the moon of an asteroid. This is important because it allows us to verify that indeed we can actually deliberately alter the orbit of an object if we need to. Another option, if you have a lot of time, is you can do something called a gravity tractor. You basically build a really big spacecraft that's big and heavy, and you park it next to the object, and you just let the gentle force of gravity change its orbit enough to make it miss. If you have less time or the object is really massive, then you have to go to more drastic steps, something like using some sort of nuclear device to try to push it out of the way. But obviously that's the last resort.
At this very moment, I say we sit tight and assess.
So NASA has actually put in place plans to deal with any potential near-Earth object impact. There actually is a national near-Earth object preparedness plan now. NASA has been doing these exercises where they bring together the international community, scientists, basically put them in a room and say, okay, here's a scenario, go. Figure out what would happen. That said, the system is really set up to be transparent, meaning that when the astronomers find an object, we really want to let the rest of the world know right away. In 2008, an asteroid was discovered by the Catalina Sky Survey, and they found that it was within 24 hours of impacting the Earth. Now, fortunately, this was a really tiny asteroid, kind of the size of about a VW bus. But within that 24-hour period, everybody got notified, and astronomers contributed hundreds of observations from all around the world. The object's orbit was figured out to be so precisely known that when it impacted in the desert over Sudan, my colleagues were actually able to go out with students from the University of Khartoum, and they collected pieces of the meteorite that it became. Asteroid impacts are not something you need to worry about in your everyday life. That said, it's not a problem that's completely negligible. From my perspective, the right thing to do is basically just go and do the kind of good basic astronomy of looking for the objects, figuring out where they're going to go, and making some measurements of things like their sizes and other basic physical properties so that we have a pretty good idea of what's out there. If we do that, then the chances of an impact ever happening that we wouldn't know about well in advance can be greatly reduced.